Hi everyone, welcome to the second lesson of Unit 1. So in this lesson we're going to talk about recursive formulas for sequences. What is a recursive formula? It's a formula for a sequence that has two different parts. So it first tells us what the first term of the sequence is, and then second, it gives us a rule for finding the next term in the sequence if we have the current term. So it's always telling us, if you're here, this will be the next term. If you know this term is 10, here's how you get the next one. All right, so we have some symbols that we use in recursive sequences, or in recursive formulas. A little u with a subscript, this is a symbol for a term in the sequence, and the subscript gives the term number. So this would be the 10th term in the sequence. And the key thing here is subscript. So that little number below the u, that's the term number. Okay, so u sub 10, we pronounce that u sub 10 or u10 would be the 10th term. So u sub 1 is the first term. And this is important because we're going to use this in our formula. The formula specifies the first term, right? So u sub 1 is going to be part of our formula. U sub n, this is a little bit weird. So this would be the nth term, where n is a variable. So basically this is saying a random term in the sequence. Any term, wherever you're at this random term. Okay, so this is a little strange, but say we're at the term u sub n. We're at a random term. The next term, to get to the next term, we would increase the term number by 1, right? So if we're at u10, the next term would be u11, so 10 plus 1. If we're at u100, the next term would be u101, so we take 100 and add 1 to get the next term number. So if we're at un plus 1 would be the term right after it, right? We've increased the term number by 1. So this is the next term after u sub n. So remember, our recursive formula has a rule for finding the next term using the current term. So we're going to use these symbols in our formulas. This will represent the current term. This will represent the next term. Oops. Okay, so let's see some examples of working with recursive formulas. First thing I want you guys to be able to do is go from a formula to a sequence. So if you're given the formula, can you write the first 4 terms of each sequence? So if we're given, u1 equals 121, we know that this is the first term, right? U sub 1 is the first term. So our sequence starts at 121. And then we want to fill in, this is being weird, the next 3 terms, right? So that's where our rule is going to come in. This says that un plus 1, so the next term, equals un, which is the current term, plus 3. So it's saying I get the next term by adding 3. So 121 to the next term will be plus 3. So my next term will be 124. Then from 124 to the next term, I add 3, right? So 127. And then we add 3 again, and we get 130. So that's the first 4 terms of that sequence. All right, let's look at another one. So again, u sub 1 equals -2. This is telling us that our first term is -2. So our sequence starts at -2, and then we want to know what are the next 3 terms in the sequence. And to figure that out, we're going to look at our rule. So u sub n plus 1, that's the next, and it's saying -3 times the current term, u sub n. So this is saying to get the next term, we multiply by -3. So -2 times -3 gives me positive 6. Then to get from positive 6 to the next, I multiply by -3 again. So that would give me -18. And then we multiply by -3 again. And 18 times -3 is 54. So that would be the first 4 terms of that sequence. All right, last example of formula to sequence. We have u sub 1 equals 0, so this is our first term. So we know we start at 0, and then we want to fill in the next 3 terms. So our rule is a little bit more complicated this time. It says that the next term, un plus 1, equals the current term squared. So we multiply it by itself, and then we add 1. Okay, so let's see if we can do it. To get from 0 to the next term, we would do 0 squared plus 1. So 0 squared is 0 plus 1 is 1. Then to get to the next term again, we would do 1 squared plus 1. 1 times 1, or 1 squared, is just 1. Add 1, we get 2. Okay, now let's get to the next term. So we do 2 squared plus 1. 2 squared is 4, plus 1 is 5. All right, cool. So that's going from a formula to a sequence. So now let's try going from a sequence to a formula. So we need to figure out what our first term is and what the rule is. So we know that we need u1, our first term, and then we need a rule for the next term. So our formula will always have these 2 parts. So first term is easy, it's right there, right? Whatever the sequence starts at, that's your u1. So u1 equals 100. Now we need to figure out the rule. So 100 to 50, I'm subtracting 50 or dividing by 2, right? And then 50 to 25, subtracting 25, so I'm not subtracting the same number every time, but 50 to 25, I am dividing by 2. So we could say we're dividing by 2 or multiplying, by 1/2, right? 100 to 50 times 1/2, 50 to 25 times 1/2. Let's try it again. 25 to 12.5, that is times 1/2. I don't know why this is being weird. And then 12.5 to 6.25, also times 1/2. So our rule would be that u sub n plus 1 equals 1/2 times the current term, or u sub n. All right, let's try another one. So we know we need u sub 1, and our rule for u sub n plus 1, the next term. u1 is easy, it's just the first term. So u1 is 3. And now we need to come up with our rule. So 3 to -3, and then -3 to -9. What's the same there? Well, okay, we're subtracting 6. 3 to -3 subtract 6, -3 to -9 subtract 6, subtract 6, subtract 6. So we're always subtracting 6. So to get the next term, we would take the current term, u sub n, and subtract 6. All right, last one, and this one is a shifted geometric, so it's a little trickier, so we'll keep in mind that it's shifted geometric. We know we need u sub 1 and our rule for u sub n plus 1. First term is easy again, it's right there. Just whatever the first term in the sequence is, so u sub 1 is 0. And now we need to come up with our rule, and we know we're multiplying and adding or subtracting. So 0 to 5, I could maybe do times 4 and then add 1. And then 5 to 21, that's also times 4. 4 times 5 is 20 plus 1. 21 to 85, so 4 times 21 would be 84. Add 1 to get to 85. So we're always multiplying by 4 and then adding 1. So to get the next term, I would take the current term, multiply it by 4, so 4 times un, and then I add 1. And you could think of right here, here's un. Un is 0 in this case, so I did 4 un plus 1. Now un is 5, so 4 un plus 1. 4 un plus 1. All right, so that's an explanation of how to write recursive formulas for sequences.